All right. So, okay. So let's start the next topic, really, which is of kinematics. Okay. So just let me get this thing ready. All right. So, okay. So you can see the screen.
Yes, I can.
All right. Great. So we'll be starting kinematics. Let's try this thing where instead of just having the notes pre-written, let's work everything. I'll write things down and let's see if this thing works. And then you can let me know that if this thing is okay with you, that I write all of these things down by myself, or just have the notes open and go through those things. You're giving your exams in October, November?
Yes, I am.
All right. Okay. Okay. So what do you know about kinematics? Anything that you would, anything that you know about kinematics? That's something that you could say. What is kinematics in your opinion? Is my question really? Anything you might. What comes in your mind when you hear kinematics? Okay, so well, it's really kinematics is a study of motion without
Yeah.
considering any effects of forces, right?
Yes,
So
yes.
it's okay. So it is really, we have a whole branch of physics which is known as classical mechanics, and in classical mechanics uh, we have really what's called Newtonian mechanics.
Okay.
Newtonian mechanics, right? Now,
Okay.
kinematics is a part of this Newtonian mechanics, where kinematics deals with motion alone, right? So motion of any points. So you have a point particle and it's moving. You can talk about its velocity, about its acceleration and displacement or distances, right? So that's what you can talk about. We'll not be considering without considering forces that are acting on the particle. So we'll not consider any type of forces. So for example, that I have a block and I push this block, for example, then the block starts to move with some velocity, right? Now, we are not concerned with this force. We are not concerned what caused the motion. We'll ignore that in kinematics and we'll only consider the motion. All right. So
Yes.
that's kinematics. Then there is something called dynamics. And in dynamics, you include the force as well. So you study how that force caused this motion. So that's
No.
dynamic, right?
Yes, sir. Yeah.
Okay,
Yeah.
great. So let's start off by discussing some of the quantities in kinematics. Now, the first quantity, really, I'm sure you know about distances, right? So distance is defined as, well, it's just a number which
Yeah.
measures how much the object has moved, right? So number
Yes.
which measures
Yes. Yes.
the movement of an object, right? So for example, you have an object and it moves from point A to some point B. Now, this number that is associated to this path is really the distance that was traveled by this object.
Yes.
Now, you can have something that is known as displacement. Displacement is really the distance. So everything holds true. So everything that I said about the distance is still valid, but we also consider direction, right? So it's really a displacement is really a distance that any object will travels from any fixed point, right? So you can consider, so a point may be fixed and you'll choose that point A to be the reference, and then you record whatever distance that my particle or the object travels. So it is the distance that an object travels from a reference point in a specified direction. So I'll explain this in a specified direction. So for example, consider that I have, you can have a block. Again, let's just consider that you have a block. Now, it can move in multiple ways. Maybe, but we'll consider this one. So if it moves in this direction, we'll assign a number to measure how much it moved in this direction. But with this number, I'll also attach something that is called the signature. So I'll say that, okay, I'll decide that I'm saying whenever my object moves to the right, I add this plus sign to this number. And I say that whenever it moves in the opposite of this direction, I'll assign a number again, but I'll add a negative signature to this.
Yes.
Now
Yes.
this, yeah, so this is purely my choice. It doesn't matter. Someone else can come up and he can say, okay, I'll choose a system where I say when the object moves to the right, I'll say I'll attach a negative signature when it moves to the right. And then he says that I'll put a positive signature when it moves to the left.
Yes.
Yeah. So these
Left side.
both are equally true. But
Yes.
once you pick one of these signatures, you have to remain in those signatures throughout your calculations. So is that clear?
Yes, sir. Sir, can you
Okay, perfect. Yeah.
please tell me the difference between the displacement and the distance? Can you please just specify that a little bit?
Oh, it's only this thing, the thing that I just explained, this signature part. When we talk about distances, we don't care about this signature. We don't care if it's moving to the right or to the left,
Direction.
or
You don't care about the direction,
yeah,
right?
we don't, yeah, exactly. So we don't care about the direction. But in displacement, direction is very important. In fact, because direction is important, we can specify displacements which are 0, but the distance at the same time is not 0. So I'll give you an example also at this point. Well, this is why we say that displacement is a vector and distance is a scalar.
Scalar, yeah, okay.
Yeah, right.
It's
So
distance is scalar and the displacement is vector, right?
displacement is a vector, right? So we talked about scalars and vectors as well in the first topic. I'll just, I'm sure you know what is a scalar and what is a vector.
Yes,
It's
I know.
scalar. Yeah, so scalar is just a number, right? And vector is a number attached to a direction. Now, this is just a very, very, very simple definition of scalars and vectors. If you go into the mathematical rigor of these definitions,
Yeah.
then you will find many
Yes.
abstract understandings of scalars and vectors. But anyways, so for example, now consider that you have a point A, and I say that I'm going to start a journey from this point A, and I'll travel around the world, and just think like this, right? So you'll travel around the world and whatever, blah blah blah, and you take a very, very fancy looking path and everything, but you come back to this point A. So you started your journey from point A, you went around all this very complicated path, but your ending point was point A as well. So you can say,
Yeah.
you started your journey from your home, you traveled the world, you came back to your home very tired, just went to bed. So you're coming back to your home. Now that's where displacement comes in, because I can attach to every point on this path a vector, and so at every tangent I can draw a vector like this, right? So I can draw vectors to every to every dot on this path. I can draw vectors. Now if I if I'm always coming back to my initial position, I can take all of these vectors and add them up and they'll give me 0.
Okay.
So because this path looks very complicated, it's not, I think it's not clear maybe, but if you consider that you're starting from this point A, and you move in a circle. So what you're doing is you're really coming back to this point, right? So I can
Yes.
draw vectors at every point on this circle, right? So these are tangents to the circle.
Yes.
Now you
In
can
math.
see clearly, yeah, so they're in opposite. So if they were pointing in the downward direction over here, on this side, they're pointing in the upwards direction. So they're equal and opposite. So when I really come back to this point A, I take all of these individual vectors, I add them, and they give me 0.
0.
So that's
Always.
why, yeah, so they'll
If
always give you
if
0.
our
If,
end starting and ending point is same, then
yeah, if exactly, if your starting and ending point are same, then the sum of all these individual vectors on that path will add up to 0. Always, this will
okay.
always be true, right? So
Got
that's
it.
why we say that displacement, if you start from initial position and end at the final position, which is the same, initial and final position are same, the displacement is 0. I'm sure you have probably seen a lot of memes on this thing as well, right? But
Yes.
anyways, yeah, so anyways, that's how you define displacement. You can
Yes.
also say that displacement is really the shortest path between 2 points. So for example, let's say you're not ending at the same point. Suppose that you have to go from point A to point B. You could have taken a very simple journey directly from point A to point B in this straight line.
Yes.
Or maybe what I could have also done is I could have traveled in the north like this, and then to the east like
Yes.
this.
Yes.
Now, in this, just 1 second, let me fix the color of the pencil. Okay, perfect. So in this example, the displacement is this distance A to B. That's your displacement. That is the shortest path that I could
Yes.
have taken to reach my point B. I could have also taken this path, which is north and then east, but that would be longer. So that's not the displacement. Those are two vectors, and you can say that they are two displacement vectors, but when you add them together, the resultant vector is this vector, let's call it D, and that is the actual displacement or the shortest path that I could have always taken from A to B. So whenever I have a journey from one point to another point, I'll always just draw these vectors of the paths that I can take, and I'll find the resultant of those vectors. And that resultant will always be the displacement. So any question so far?
Do we also call this the last part that you explained? Do we also call this as a resultant force, the final one?
We call it as a resultant displacement. Resultant force is also another concept, by the way. But
Okay.
the concept of, okay, so let me just clear that over here. So the concept of resultant applies to vectors. Now, you could have different vectors, right? So suppose some of the examples of vectors are displacement, right? Force, velocity, and we have many more, right? So etc. So resultant is a concept that applies to all vectors. Now resultant displacement would be a resultant displacement when I basically add these two different displacement vectors, right? If I find the resultant of those, that would give me resultant displacement. Similarly, I can have two different force vectors. So for example, I have a force vector that points like this, and then I have a force vector that points like this. So these vectors are acting, the force is acting on this dot that I drew. So it could be a ball or anything. Now I can find the resultant of these two forces, which would be this one. So that's so the concept of resultant is applicable to vectors, but we have different types of vectors: displacement, force, velocity, and more. So you can always find resultant displacement, you can find resultant forces, you can find resultant velocities. So the one that we were talking about, our vector in this case was displacement, right? So that's why we said that this is the displacement, resultant displacement.
Okay, sir.
So is that clear?
Yes.
Okay, great. Wonderful. So that's displacement. Now we can also define speed, right? Now speed, I'm actually defining something which is that I have this distance, right? So I have a distance between 2 points. Now that distance may change with time. So speed is given, so the distance changing with time is given a name, which is speed. Now, so speed is really defined as distance changed in or you can say per unit time, or in some unit time. Now what this means is that, for example, you have a distance between these 2 points, right? So this is the point A and point B. The distance between these 2 points is something, let's just call it small d. Now that's the distance between these 2 points. The distance may increase or it may decrease with time. So what I mean is that this point B, maybe this point B, let's consider point B. Let's say point A is fixed. So point B may move further away. So in this case, distance has increased, right? So I can extend this line as well. So the distance has increased, right?
Increased.
Yeah. So, and on the other hand, what might happen is that, 1 second, let me, okay. On the other hand, what might happen is this B might come closer towards A. And in this case, we can see that the distance has decreased. It has become small. So how does the distance change? Because of the movement of B. So B might have had some speed, a quantity that is called speed. So because B had a speed, that's why the distance changed. So distance is, speed is really how distance changes in unit time, right? So
Yes, sir.
now in terms of speed, it doesn't matter where B moved. We don't care if B moved to the right or B moved to the left. We just care that distance increased or it decreased. We just care about the number. But when we talk about, so when we talk about displacement, how does displacement change in some time? In that case, because displacement was associated to a direction, this thing is given a name, velocity. So now if I have the same thing, A and B, and the displacement between these two is this line, let's call it small s meaning displacement. Now it matters if my B is either moving to the right, then the distance will increase. And if my B moves to the left, then distance decreases. So if we care about this thing, that how does my B move and distance increase or decreases? So if we care about the increase in distance or the decrease in distance, then I need to understand, then I need to know where is B moving? Is it moving to the right or is it moving to the left, right? So I can say that if the point B moves to the right, then the distance has increased. So I have this knowledge now. And if I tell you that B moved to the left, then you will tell me that the distance has decreased. So just by telling you where B moved, you can tell me about the increase or decrease in the distance. So that's what we call velocity. So the direction is important. So that means that B has some velocity. So is that clear?
Okay. Yes, sir.
Okay, great. So now we can also talk about acceleration. Let me first give this a mathematical expression. Everything that I have told you so far was in English, really, and with visual expressions. But mathematically, I don't know if I spelled that right, but anyways,
No
mathematically,
problem. No problem. Yes.
yeah, mathematically, whatever, right? Whatever the spelling is,
Yes,
mathematically,
yes,
we
no
need
problem.
to assign uh, in physics, really, everything uh, is written in terms of mathematics. Any statement that you give in physics, you have to write it in mathematics, because physics is, it's a science, of course it is, but it relies on the language of mathematics. So as long as you have the mathematics to back something up, back up your statement, then you say that that thing is true. Of course, provided that the mathematics behind it is true. So, converting this English into mathematics, that distance changed in some unit time, it just means that mathematically I can say that speed is really some distance d divided by, which means per unit time. So distance divided by time, which means that how much distance it covered per unit time, right? So that's speed.
Yes.
In similar way, I can write down velocity mathematically, giving it a symbol v, and I add this arrow on top of it, telling you that it's a vector quantity. So then that is equal to the displacement, change in displacement. So S with a vector, where S is the displacement vector, divided by the time it takes to change that displacement. So that's mathematical expression for velocity. Now, similarly, we can talk about acceleration. We have acceleration. All right. So now, of course, we talked about distance or displacement, and we said that that displacement might change, right? And the change in that displacement was given a name, and that was velocity. Similarly, I can then say that my velocity might change as well with time. So that is given a name as acceleration. So acceleration is the time rate of change of velocity, which means the same thing, that it is just the change in velocity per unit time. That's the meaning of this time rate of change of velocity. Now, that's your acceleration. And so the mathematical expression for acceleration is a vector is equal to velocity vector divided by time. So it's the change in velocity per unit time, right? Now that's acceleration. Now we can talk of something, there are some interesting facts with this acceleration. So we'll discuss those. First is the case where we would have a positive acceleration. Now, positive acceleration is when I have an object and it's moving in this direction, suppose. Now, if the acceleration vector points in the same direction as the velocity vector, then the acceleration is positive, right? And what would happen in this case? The velocity would start increasing because the velocity vector already points in this direction. Think of an acceleration vector as it's pulling the velocity vector. So it's trying to increase, stretch the velocity vector. And if the velocity vector stretches, it will increase the distance. Sorry, it will increase the velocity, right? So because we know that you can use this analogy, by the way, because we know that force is ma. So which means that whenever I have an acceleration, there is some force acting on the system which has produced that acceleration. So you can think of this acceleration vector as something that is pulling on this velocity vector in order to stretch it. Now, if it is stretching this velocity vector, it will increase the velocity in this direction, right? So is the concept of positive acceleration clear?
Yes, positive is clear. Yes.
Okay. Then you have a negative acceleration. And negative acceleration is also called deceleration. And the name really says it all, that now if you have a box, an object, and suppose it was moving again in this direction, so the velocity vector points this way, but the acceleration vector points exactly opposite to this velocity vector. In that case, the object is moving to the right, but there is some force trying to pull it back to the left. So imagine the situation in your head that someone is pushing a box, but you're trying to pull it back towards yourself. So what is happening? You're trying to slow it down. You're slowing the box down. So what you're doing is you're decreasing the velocity of the box. So the velocity will start to decrease in this case, right? So negative acceleration decreases velocity.
Sorry to interrupt you. Can you just
Yeah,
please
no,
describe it again, like the negative one?
of course, no problem, no problem. So imagine a situation in your head where you are standing over here, right? And you're so there is, you can consider that there is a car which is moving on the road, and you tie a rope to this car and you try to pull it backwards, but the car is moving in this direction. So the velocity vector points here, but because you're pulling it to the left, so the acceleration vector is pointing to the left. What would happen to the car if you pulled hard enough? And I mean, in a practical situation, it's really hard to stop the car, but at least you would somehow slow the car down, right? You'd slow it down. You decrease the velocity of the car, right? So that's what would happen. The car's velocity would start decreasing because the car would start slowing down. So that's negative acceleration, that you have added this negative acceleration to this car or this box, and that had decreased the velocity of this car or any object for that matter. So negative acceleration is there to decrease the velocity. So is that clear?
Okay, sir. Sir, in
Okay.
the previous
Yeah.
sheet, like you said, everything is to be represented mathematically. So can you please show that me again? It just clicked my mind to see it.
On this page?
Yeah, the previous one.
All right. Okay. So are you talking about this thing?
I can't see it.
Oh, I think maybe because of slow connection. Can you see this page now?
Yes, I can see it.
Okay,
Okay, so
great.
these are just the formulas, right? Speed is equals to distance upon time, and what is the down one?
It's velocity v vector is equal to
Okay.
displacement. S is for displacement, right?
Yes, yes.
Displacement per unit time.
Time. Okay, okay. Got it. Got it.
Right? Okay,
We can
great.
get back now. Yes. Thank you.
Okay, no problem, no problem. All right, so here are these two cases, right? Positive and negative acceleration. Then you can have another case where the acceleration vector is perpendicular to the velocity vector. This means that suppose that I have an object and this object, suppose it's a ball and it's moving in this direction. So the velocity vector would point in this direction. However, suppose I apply an acceleration to this, which is perpendicular to this velocity vector. Perpendicular means that it is to the right angles of this velocity vector. So the acceleration vector is this one. So you can see that it is at right angles to this velocity vector, right? In this case, the acceleration vector is independent of velocity vector in a sense that the velocity vector is completely in a horizontal direction, right? While the acceleration vector is entirely in the vertical direction. So the acceleration vector will not be able to change the velocity vector's magnitude. So if something was moving with 2 meters per second, for example, it would still keep moving with 2 meters per second, but the acceleration vector would change the direction. So because this vector points in this way, it would try to change the direction of this ball in a curved path. So the ball, which was moving like this before, it will start moving like this in this curved path now because of this acceleration vector. Now imagine a situation that you have, just imagine that you have any object that is moving in a particular direction and you apply a force perpendicular to that direction. So what will happen? The direction of this object will change. You can just, if you have a book on your table right now, just try to push the book, keep the book moving in one direction with a finger, and then with your other hand, apply a force exactly perpendicular to that direction of motion. So
It
for
will
example,
form a
what I'm saying,
it forms a
yeah,
curve like, you know.
yeah, it forms a curve like thing, right? So you get the point, right?
Yes.
So that's what happens when acceleration is perpendicular to the velocity. It will not change the magnitude of the velocity, but it will change the direction. So the
What
velocity
will be the
vector,
radius of that curve or that circle? If it keeps on, it will form like a circle. And then how will we determine the radius of that circle?
oh right, so you can do that, but at the moment that is really part of mechanics too. You study a circular motion, which you'll be doing in two-level physics, right? And you can do that by understanding the angular velocity of this path, which is really denoted with omega, and then you can find the radius by deriving really an expression for the radius in terms of the linear velocity, which is this velocity. And they are really related, as a linear velocity is radius times the angular velocity. And from here, you can conclude that. But at the moment, let's not get into that. You're just taking AS physics at the moment, right?
Okay, okay.
You're at this point, you're only taking AS physics,
Yes.
or right? You're not taking A2 as well, right?
No,
Only.
no.
Okay. So I mean, it's a very interesting question that you asked, for which you'll find an answer when you move towards A2 level physics, where you study Newtonian mechanics 2, and in that there is a topic called circular motion. There we can understand this thing in a much better perspective, right? Okay, great. So that's acceleration, really. Now we can let's try to do an can you tell me how much time is perhaps left? I think 6 minutes at most, right?
Yeah,
In the
maybe
meeting,
4 minutes
because
if it's a 40-minute class.
yeah. Okay, so we'll consider an example, and let's see if you understood the idea of speed and velocity, right?
Yes,
So
why not?
consider that you have a train. Suppose it's a train, and it's moving in a circular track, right? So the train starts its journey and it moves like this, and like in this direction. and it moves along this track. The circumference of this track, which means the distance from this
Yes.
point all over
Yes.
this circle, is